Hello, everybody. It's Steve. I am having Claude port this the algorithm behind this Seattle Delivery Network from TypeScript to Zig. And Claude basically wrote about 2,400 lines of Zig in the last hour or so. Normally, Claude does not write 2,400 lines of code per hour, but in this particular case, Claude was porting a program that it had already written in TypeScript and had created um, gold files for the TypeScript algorithm. So the Zig code was just targeting the algorithm. And Claude has just reported back to me that the solver port is done. 20 of 20 gold shifts bid exact on the first complete run. Claude has written to my essay surface here with more detail. The delivery solver now speaks Zig, 20 of 20 bid exact first try. We're right in Claude's wheelhouse. Claude knows how to read TypeScript. Claude knows how to write TypeScript, of course, because it wrote the original TypeScript code here. And it knows how to write Zig. So my prompt right now is go. Simple as that. I'm just telling Claude to keep going. So Claude is going to take the TypeScript algorithm, or excuse me, the Zig version of the algorithm for distributing orders among the trucks and integrate it into the browser bundle. This is the program running in production. This is still TypeScript code here. Got a bunch of houses in Seattle that are randomly picked according to a seed. So when we saw earlier 20 of 20 gold shifts, each of those shifts represents a different seed for the random number generator. So it's random and deterministic at the same time. But basically, Claude has re-implemented the algorithm from TypeScript into Zig and is now making it so that we serve it up in the browser. So you can see that when I said go, it says the swap in stage. First, I needed to know exactly what surface the browser consumes from the solver. So it's reading the existing TypeScript code to figure out how to make that integration. And let's see, it's running this grep command basically against the code, against build Safari. Okay, that's interesting what it's doing right there. It's reading the build program for another program that had previously been ported from TypeScript into Zig to figure out the mechanics of how to have a browser use TypeScript to kind of like control the actual display, but then to have Zig do all of the lower level algorithm stuff. But I'm going to go ahead and let it do what it needs to do to keep running. And we can go back to this essay surface. Okay, again, Claude is telling me that the delivery solver speaks Zig, 20 of 20 shifts. So a shift here, we're on shift S1. If I hit S to get another shift, it just creates another random shuffling of orders among the trucks. Keep doing that. Shift S3 will be yet another random configuration of orders. And you can see that the trucks are generally delivering to houses that are in the same general vicinity. The whole purpose of the Clark-Wright algorithm is that you don't want to have every truck going all around Seattle and delivering to every neighborhood because that would be really expensive. Instead, you want to divvy up these 8 trucks so that each truck generally handles about 2 or 3 neighborhoods. Like you can see the green truck here, which is truck 3, handles Ballard, Fremont, and Medina, or maybe Medina. I don't know how that's pronounced actually in Seattle East. I do know most of the neighborhoods. This particular truck is truck 2. It is doing Magnolia, Queen Anne Hill, and downtown, so on and so forth. But anyway, Claude is telling me that the delivery solver speaks Zig, and what loose ends, whether the next. Okay, so it's open when you want it. The next step is either the Safari style WASM WebAssembly swap in, which is what I did. And I think that's really all I really needed to do. Let me read this. The 1 zig byte min 3 and -1 doesn't just clamp the value. 0.16 refines the type to U2, so max K plus. Okay, so it in the port, it discovered some nuances about Zig that it didn't know from its training, because it probably trained on an earlier version of Zig than 0.16, but it was able to figure it out. And Claude is good about telling me little details like that. This particular detail, I mean, I understand what overflow means, but this particular detail is something that's probably a little too low level for me to need to verify. Like, I'm completely confident that Claude understands overflowing integers just as well as I do. But it's good. I tell Claude to give me probably a little more detail than I need to have, because sometimes, even though I might not know the exact technical details as well as Claude does, I can sometimes smell when Claude is doing something, when Claude is focusing too much on a particular technical detail, or I can just tell sometimes that Claude is going down the wrong path without understanding every technical detail. But it is just working away now on wiring in the WebAssembly for Zig in the current program that's all 100% TypeScript now. After this step, we will expect that the program that you see here, after I deploy it, we'll test it locally first. This program will be doing all of the drawing still in TypeScript. So TypeScript will control the canvas and control the animation. Like, when you can actually animate all of each truck is like this little circle here, and as it makes a delivery to each home, the little square for the home turns into a checkbox. All of that animation, at least for now, will continue to be in TypeScript, but the actual algorithm, the variation of the Clark-Wright solver that we used to have in TypeScript, will soon be in Zig. So it's just working away. I'm going to end the video right there. Thank you for watching.